Hi, this is Vijayakumar, Assistant Professor, Department of Physics, SNS College of Engineering. Today I am taking the class of Crystal Physics overview. So today we discuss the crystal physics. The crystal we have used in many places in our application oriented. Right? For example, is a liquid crystal or solid crystal. Most of it is a form of solid crystals. Right? The application of solid crystal is all the chemical nature is a form of some structure. The structure is based on that crystal nature. So the 7 types of crystal structure is forming that any types of the chemicals, especially in solid phases. Right? So we have fabricated in a micro level crystal to the meter level crystals to the form of different types of method. Especially we have used in method, the form of Bridgman and Zuralski method. These two methods is form of crystal. Right?
Symmetric and asymmetric.
The symmetric and asymmetric. The symmetric means the atoms are arranged in a periodic manner in a regular structure to the form is called as a symmetric. Asymmetric is in a random direction atom alignment of lattice manner, that is asymmetric. Moreover, the crystal is formed in symmetric nature. Okay, it's not a form of asymmetric nature because the structure is clearly formed in a crystals. That's why we form in symmetric nature. Right? Then any other?
So, what is meant by five-fold symmetry and why it is absent in crystal structures?
Five-fold symmetry means the 5 atoms are joined together. It's a form of five-fold symmetry. But actually, the crystal structure is a form of hexagonal formation. Hexagonal means it's in a 6 atoms combined to form a covalent bond structure. Is a 6-fold symmetry. But this is a 5-fold symmetry. Most of this absent because the bond nature is becomes a form of weak, so it's easily to be broken. So it's not a form of clear structure in the crystals. So that way we have avoided or is an absence of 5-fold symmetry in a crystal structure. Right? Then we found in some basic parameters we have classified in the crystals. Right? And we have analyzed from some properties wise is a defects and non-defects. Defect is also performed in many categories wise, form of atom, molecules, ions, impurities, and surface levels is all to defect to the forming crystal. Right? So this is the overview of crystal. Then the continuation we have discussed in the next class.
Thank you, sir. Thank you for your time.
So the basic structure of crystal is a form of 7. The 7 types of crystal system to the form of 14 types of unit cell, that is the form of Bravis. Bravis is based on the Miller indices. So the one by one the property of crystal and also the parameter of the crystal, one is in a angle and another one is in a side. So this based on this parameter and properties, the crystal will be categorized into different structures. The based on the structure, the number of atoms will be occupied and unoccupied and strength and the material classification is formed in that. So the crystal is not only for the single word, it's a use of the many of application in industries as well as the medicals. So the crystal physics is a very important topic to study in all the engineering and the science students to the form of some research also. Thank you very much. The application of crystal is in a hardness and wear resistance and oxidation resistance. It will be used in aerospace and automations, then surgical and medical instrumentations, dyes and the others, then cutting tools, firearms. These all we have the form in the application oriented in a crystal physics. So the application is a very long usage of crystal. So we have created in a long crystals and as well as in micro crystals. Thank you.
This overview of crystal, sir have explained about symmetric, asymmetric, and also why five-fold crystal, five-fold bonds are not used in crystals, and also explained about the crystal formation and the applications of crystal. This was very useful for us.